On this program, nature and technology, computers and privacy, genetics and the human race. The saga of humanity's struggle to overcome the animal condition began with the making of tools in bone, wood, and stone. Since then, man has domesticated the atom. Unfortunately, that feat gave us nuclear arms. The road to progress is full of risky booby traps. Since the very beginning of the human adventure, our ancestors have had to display considerable resourcefulness in order to stay alive. Hundreds of millennia ago, human beings seemed disadvantaged compared with most other mammals. They had no fangs, no claws, no horns, nor were they particularly swift-footed, strong, or agile. However, the naked ape was not without skills. He had a mind that could conceive things, and hands that could make things. He could store the knowledge he acquired in his brain and use his hands to perfect his technique. It is no wonder that this misfit sought to adapt the environment to his needs, and in his quest, his weapon was the implement. The first implements humans used were made of wood, bones, and stone. They were rudimentary and only crudely extended the hand, allowing the user to scrape, cut, or pierce. It was thanks to tools that emulated the weapons nature had given the other animals that man's hands became his fangs, his claws, or his horns. But man was not content to merely imitate nature. He went further. He innovated, and he discovered. If he bound a cutting stone to a haft, it strengthened his arm tenfold. He therefore invented the axe and discovered that the law of the strongest is itself subject to the laws of physics. So, from invention to innovation, the human species has evolved through the centuries, acquiring ever-increasing control over nature. Around the end of the 19th century, things happened very quickly. It was the golden age of the great inventions: the telegraph, photography, the gramophone, the electric bulb, the automobile, and so on and so forth. Ironically, however, the 19th century also marked the disappearance of the great inventors, as technique ceased to be a craft. From then on, all the major inventions have come from corporations rather than individuals. Thomas Edison invented the phonograph, but a multinational invented the laser. Technology radically changed our relationships with objects and our relationship with the world. First, the knowledge invested in objects is so complex, it obscures how they actually work. The fields of scientific knowledge are now so numerous, no one person can be proficient in them all. Indeed, there isn't one person on Earth who could tell you in detail how all the components of a simple compact disc player work. The skills that go into designing and developing a CD player are simply too numerous and too varied for any one individual to grasp. It is the result of a pooling of knowledge. A century ago, an individual could easily keep a ship's blueprints in his head, but hundreds of brains need to be mobilized to store the blueprints of a space shuttle orbiter. If objects are designed through a meeting of minds, as it were, the same can be said of their manufacture. In the 19th century, a skilled carpenter was able to perform all the operations required to build a roadster. Nowadays, a car is made by an army of technicians working on an assembly line. Technological development has greatly contributed to the expansion of the industrial societies. The power of these nations was strengthened when the traditional tools gave way to machine tools and workshops to production lines. At the same time, the division of labor was introduced in response to the multiplication and specialization of knowledge and skills. And division of labor is crucial to using the tool of all tools, the factory. The organization of work, a legacy of industrial production methods, left its stamp on the way our societies function. People's schedules are now governed by their work hours. Daily life beats to the rhythm of production. Human beings are not only subjected to the new technological order, they depend on it. How would they ever manage without the myriad of gadgets that make life easier and hassle-free? From the automatic washing machine to the pacemaker, objects protect us against life's little problems. But above all, the human species now has the means to its ends. With its gigantic implements, it relentlessly works the whole planet. Clear-cutting the forests, leveling the fields, harnessing the waterways, navigating the seas, and flying the skies. Homo technologicus is reshaping the earth as he sees fit, artificially recreating the world so he can substitute it for nature. Originally, technique was a strategy to ensure our survival. Today, however, it rules our lives. And nature has been relegated to a position of secondary importance. Who hasn't at some time or other received a computer document, a statement from an automated banking machine, or an electricity bill? Computers make our lives easier, but they also raise an important issue: the protection of personal information, our right to privacy. The free movement of information is fundamental to all democracies. But as communications technologies make access to the sources of information easier and easier, a problem arises, that of confidentiality. Satellite and fiber optic telecommunication systems, coupled with the power of computers, form a global network of high-speed data highways. The information is stored, analyzed, and managed in real time. The planet beats in unison. Since the beginning of time, public or private organizations have kept files in which they classify information on their clientele. Back in year 0 of our era, Caesar Augustus decreed that all the males in the empire had to register at their place of birth. The census-taking task has since become much easier, and with the advent of the computer, personal files have multiplied at a rapid rate. There are now countless databases capable of taking the census of entire populations. Obviously, any democracy worthy of the name has adopted laws to govern the collection of personal information. This is, of course, to prevent the creation of super data files. When the Berlin Wall fell, it came as a shock to many when the files of the Stasi, the secret police of the former German Democratic Republic, were discovered. Not only had files been kept on the whole of the population, but the secret police had also, for its own use, compiled all the personal information found in other files throughout the country. In our Western democracies, we needn't worry about a totalitarian threat, at least for the time being. Information is gathered in a civilized fashion, without anyone having to resort to police methods. Some files, however, contain sufficient information to provide a precise profile of every citizen, one that would strip them just about naked. The government has the right to know, to be sure, but each citizen is entitled to his or her privacy. Computer technology has made that already tenuous balance of rights even more difficult to maintain, because thanks to computers, there is such a thing as a superfile, albeit a virtual one. And in principle, networking databases would make it possible to update that superfile at the expense of the individual. Through comparisons, record linkage, and data coupling, a person's complete curriculum vitae, composite picture, could be drawn up. So the access to computer files must be restricted, and the information in them prevented from falling into the wrong hands. This is especially true where benchmark or sensitive data is concerned. Sensitive data is information that deals with an individual's physical and mental fitness, ethnic background, religious and political beliefs, sexual behavior, financial situation, and even IQ. All this data constitutes susceptibility indexes on the basis of which a person might become the victim of discrimination. The file's secrecy therefore raises the issue of system security. By and large, the solutions to these problems are technical. For example, the files in some systems can only be consulted with a personal security access code or a magnetic card. And every time, when, by whom, and why the file was opened is recorded. This information is later added to the file itself, so both the agencies authorized to consult it and the person concerned can see it. Of course, there will always be loopholes, as there will always be hackers, those inquisitive computer whizzes who manage to break into some of the best protected systems, whether just for the fun of it or for personal gain. That's why institutions have to resist the temptation to gather superfluous information. Because under certain circumstances, superfluous or trivial information can become compromising. We might wonder whether the proliferation of personal files might not lead to a society watched over by computers. And yet, the usefulness of such files is beyond question. They represent, for instance, a goldmine of information for researchers in sociology, education, industrial medicine, and especially epidemiology. It's up to the policymakers to strike a balance between public safety and protection of the individual. If we're vigilant, everyone stands to gain from these new technologies. It's our job to make sure that in our democracies, some citizens do not become more equal than others. When it comes to medicine and human biology, ethical issues take on a whole new dimension. Thanks to biotechnology, we now have unprecedented control over what matters to us most, life itself. Since the turn of the century, medicine has made phenomenal progress. It owes it to the findings of basic research and the development of biotechnologies. However, science's increased control over the living raises a number of ethical issues. In 1953, Watson and Crick proposed the double helix coil for the molecular structure of DNA. This long molecule holds all the information living things need to function. When they did, they opened up a whole new field of molecular biology, namely decoding of the alphabet of life. The letters of the alphabet are called codons. Each codon is a sequence of 3 adjacent nucleotides, composed from 4 bases: adenine, guanine, cytosine, and thymine. The sentences of the text are the genes, sequences of a few hundred to several dozen thousand codons. In humans, these genes, estimated to number about 100,000, are divided between the 46 chromosomes contained in the nucleus of a cell. Many biologists have made an effort to learn the language of life. In it, they saw a chance to understand how some genetic diseases express themselves. They also hope to discern the coding errors that sometimes occur in the genetic inheritance of certain individuals. For example, some diseases called monogenic are caused by the faulty listing of just one of the codons in a gene sequence. Cystic fibrosis is one such disease. The scientists have managed to identify the defective gene in people with cystic fibrosis. With prenatal diagnosis, it can even be detected in the fetus, which can put the parents in a terrible dilemma. Indeed, why bother establishing a prenatal diagnosis of a disease we cannot cure, except by induced abortion? For some, it opens the door to a form of eugenics, to the artificial selection of humans. For the researchers, though, the identification of the defective genes is only the first step in a process aimed at correcting the errors that cause monogenic diseases. That process is gene therapy. It consists of implanting a healthy gene into a cell nucleus to replace the defective one. Technology now enables us to introduce foreign genes into the genetic inheritance of an organism. Some researchers can lay claim to the paternity of species of animals and plants whose genetic material is brand new. On this momentum, the Western countries have allocated researchers considerable budgets to establish the sequencing and mapping of the human genome. And then what? Will we ourselves still be able to draw the line between normal and abnormal? What's to prevent some Dr. Frankenstein from taking out a patent on a superior race? Or parents from programming the features of their future children as they would like them to be? Thanks to in vitro fertilization, parents are now able to schedule the birth of their baby when convenient. This is done by using a technique borrowed from the agri-food industry, which consists of provoking a hyperstimulation syndrome. Up to about 20 oocytes, eggs before maturation, are collected and fertilized in vitro. Then 3 to 9 embryos are implanted in the uterus. The surplus embryos are frozen and stored. In actual fact, this technique is more of a palliative procedure than a therapeutic action. It is widely used on hypofertile couples, couples who are not very fertile, but who, with a little patience and goodwill, might see their efforts rewarded by nature. The individuals involved are therefore not in any way ill, just impatient. As for couples who really are sterile, in vitro fertilization will perhaps allow them to conceive, but it will not make them fertile. A scant 5% of these procedures result in the birth of a child who is alive and in good health. The high costs involved are out of proportion with the priorities of any public health care system. There is clearly something adrift in this kind of medicalization of procreation. But above all, these practices raise serious ethical problems, particularly with respect to the surplus embryos that are piling up the freezers of fertility clinics. Does the mere consent of the parents, who leave their frozen embryos to science, constitute sufficient approval for clinicians to keep them in their banks? An ethical problem such as this will not be resolved by those who would collect human embryonic material, no more than by their colleagues who are so eager to study it. Scientists have their own preoccupations, which may not necessarily be society's.
If science is to advance, we must overcome our fears, but display caution as well. For science has now given us power that would make any god jealous.